Serverless is on the way to fulfill the promise Heroku gave us a while ago. It aims to simplify operations and enable developers to focus on business logic without having to worry about underlying hardware, operating systems, and other infrastructure and services that might be required for an application to run. What's not to like about that promise? If you use serverless as a service provided by a vendor, you might end up with a vendor locking, or you might realize that you are too constrained. For some, heck, for many, that is not an issue, but for others, it might be. Even if you're in the former group of people, if you don't have any issue with being locked in or constrained today, you might realize later that the constraints prevent you from doing what you're supposed to do. That's the nature of SaaS offerings. They're simple, but they're also opinionated. And when those opinions do not fit your needs, you are in trouble. Now, the alternative to that is to build your own serverless computing platform, and today, that will be the focus of this video. Let's start with the definition of serverless computing. The short version is that serverless computing is all about the ability to run your applications without having to worry about underlying infrastructure and backing services. You run your apps and someone else takes care of the rest. There is a problem though. It all started with AWS Lambda and a few other similar services. Those are great, except that they formed a wrong image in people's heads about serverless computing. You see, AWS Lambda is FaaS, or Functions as a Service, and due to its rise in popularity and the fact that it was one of the first services of its kind, people started to think that serverless computing is all about functions. It is not. It's absolutely not. Functions as a service is just one of the ways to run your applications in a serverless way. There are others, like, for example, containers as a service, or CAS, WASM as a service, and so on and so forth. Think of all those, and many others, as different flavors of serverless computing. Now, with all that out of the way, how would we build a self-managed serverless computing platform? We would probably start with Kubernetes, since it provides quite a few benefits out of the box. It has an extensible API, is declarative, it can schedule workloads across nodes of the cluster, and so on and so forth. You know what Kubernetes is, right? So I don't have to dive deeper, except to say that it is a good starting point. There are plenty of choices for building stuff. It could be cloud-native build packs, Builda, BuildKit from Docker, or Docker itself, Kaniko, or something else. We would also need to figure out how to orchestrate building of those images no matter which tool we choose. That might lead us to adding a build orchestrator like Shipwright that spins up Tecton pipelines to run tasks. Next, we need to figure out how to run those binaries packaged as container images or WASM or something else. That's where Knative comes in. It is more or less a standard for running serverless applications in Kubernetes. We need more though. For example, we need scaling so that the application can scale to 0 when there are no requests and scale up when there are. That can also be done with Knative, but there are other options like, for example, KEDA. Also, we might need to figure out how to connect applications to each other's and how to trigger scaling when simple HTTP triggers are not enough. The logical choice for that type of tasks would be Dapr. Finally, we also need to figure out how to connect all those and other things we might need. We need something that will stick all those together. Now, there are two ways we can accomplish all that. We can make a selection and, let's say, choose to use Buildpacks and Knative and KEDA and Dapr and write our own glue that will connect all those. That is a perfectly valid approach, and if that's what you would like to do, you might want to stop watching this video and go through those first. Once you're experienced with those, there are quite a few other pieces of the puzzle you would need to figure out, and once you do, you're not even close to finishing. You still need to combine all those into a single platform and make sure that they all work together. Now, before you go off and start doing all that, I must tell you that there is an alternative. There is a way to get all those pieces of the puzzle combined without having to do it yourself. That's where OpenFunction comes in. OpenFunction is a cloud-native open source FaaS, functions as a service, platform aiming to let you focus on your business logic without having to maintain the underlying runtime environment and infrastructure. Now, that was the official description of the project, and I think it is very, very misleading, or to be more precise, it is not true. It's bull. Now that you know that I called bullshit on the official description of the project, let's see it in action and comment on it while we do. We'll make a very quick break to thank CastAI for sponsoring this video. CastAI is likely one of the best and fastest autoscalers on the market. It works with Kubernetes, and apart from normal servers, it also supports GPU nodes. So those working with AI and ML are covered, very well covered. And if you want to save on your bills, it works with spot instances as well. It's a wide-reaching automation platform for Kubernetes that automates cost optimization and removes the need for you to manually fiddle with resources. Try it out for free. Now, let's get back to the video. We will start with functions, but if that's not your cup of tea, let me assure you that we will get to normal applications as well. So this is not only about functions, this is about serverless. And here's the source code. Now, before you freak out because the code is in Go and not whichever other language you prefer, let me tell you that I'm keeping it simple so that you can accomplish the same in any of the supported languages. I'm importing the OpenFunction library, which mostly serves to provide routing functionality. Then there is the mandatory init function that defines the routes that will be used to trigger the functions. The rest is whatever you want it to be. In my case, there is root handler that outputs a silly message. There are a few others related to handling database operations, but there is probably no need to go through those since they follow the same pattern. I did say that it will be easy and that no special Go knowledge is required. And I hope that I got you there so far. Now, let's build a container image before we run it as a function by executing pec build, specify OpenFunction Go builder, and a few environment variables that will tell the system the name of the function and to clear the source of the function. In this specific case, I used buildpacks to build the container image. That's very, very handy since I do not need to define a Docker file. The build itself might take a while longer since this is the first time I'm building it and there is no cache. So let's fast forward to the end. And now we can run the function packaged as a container image by executing docker run followed with a few environment variables and the port that should be published. Now, those environment variables are just silly, and I would have expected OpenFunction to bake them into the container, but that's not a big problem since most likely you would define those in a Docker Compose file instead of typing them every time you would like to run the function locally. Now, later on, I will argue that running functions locally with Docker is useful only with very simple scenarios, and when things get more complex with, let's say, dependencies on other functions and databases and queues and others, its usefulness diminishes very, very, very quickly. We will get to that part later. Right now, I want to check whether my function is working as expected. So send a CURL request to localhost, and there we go. We got a response from the function. It was simple and it's working and it's mostly useless. I could have accomplished the same without OpenFunction, honestly. But, as I already said, we'll get to that part later. Now, I want to move to the real deal, the real reason why I'm showing you OpenFunctions. But before I do, let me remove the container by executing docker container rm. Running functions as local Docker containers might be useful when developing them and when there aren't many dependencies. Even if that's good enough for you, you almost certainly do not want to run functions in Docker containers in production, right? That would defy one of the main reasons why we would want to use functions in the first place, since that would result in no autoscaling, there would be no scheduling, and so on and so forth. You know, the good things that Kubernetes gives us. And you can probably guess where this is leading to, right? We will run it in Kubernetes, and it all starts with the definition of a function resource So let's take a look at an example I prepared. This is a Kubernetes custom resource definition based on function CRD. The spec contains some basic data like the version of the function, the image we want to build and run, and the reference to the secret with the credentials that will be used to push and pull image from the container registry. Now we're getting to the interesting part with the build section of the spec. Over there, I specified the builder, which is the image that will be used to build the container image. The same environment variables I used when building the image manually with buildpacks, and the source repo that contains the code that should be built. The serving template section of the spec contains the information about the containers that will be used to run the function. The name should always be function and the rest is optional. In my case, for example, I'm defining the environment variables my function will use to connect to a Postgres database. Besides the template, I also set serving triggers to the port 8080, which means that the function will be triggered by HTTP requests sent to that port. I could have set many other options, like, for example, custom scaling parameters, but those I specified right now should be more than enough, I guess, to get us started. Now, if you're used to Docker Compose, this might seem like a complicated setup, but it's not, considering that it will do much more than Docker Compose could ever do. An image will be built, a function based on that image will be run, it will be scaled up and down based on the number of requests, and so on and so forth. All that will be accomplished by creating quite a few low-level Kubernetes resources like, for example, deployment, services, HPA, routes, and so on and so forth. So, even though that manifest contains some 30 to 40 lines of YAML, once you see what it's doing, you will realize that we would need to write hundreds or even more lines of YAML to accomplish the same result and many more to set up the system in the first place. This manifest contains only the information that is truly needed to run everything. There is no boilerplate code, no duplication, and no low-level details that might be incomprehensible to many developers. This is a proper abstraction that hides all the complexities behind a simple interface. It would take an enormous amount of time, even to most experienced Kubernetes experts, to set up a system like this from scratch. Now, you might think that I'm exaggerating, so let me skip the rest of the pep talk and show it in action. Normally, I would push that manifest to Git and let Argo CD or Flux take care of synchronization, but for the sake of keeping us on track, I will do what should never be done and apply directly to the cluster by executing kubectl apply. And I will retrieve all the functions from the A-team namespace. Now, we can see from the build state that the function is being built. So let's fast forward a bit until that's finished and the function is starting. Many things happened as a result of applying that manifest. One of those is that the container image was built and pushed to the container registry. I can confirm that by opening container registry where I keep my images. As a side note, container registry, which is the name of the service, is a SaaS version of Harbor, which I explored in that video. Now, the good news is that OpenFunction demo image was indeed pushed to the registry and it was tagged as 001. The bad news is that it has 5 vulnerabilities. That's no bueno, and surfaces one of the problems with OpenFunction, which we will discuss later. Looking at the UI for more than a few seconds hurts my eyes, so let's go back to the terminal session. Now that the function is up and running, we should probably test whether it's working properly. Specifically, I want to check whether other applications can connect to it, whether users can connect to it, whether it is connected correctly to the database, whether it scales up and down, and whatever else might come to my mind in the meantime. We can get the addresses associated with that function by retrieving status addresses from the function resource by executing kubectl namespace is A-team get function and outputting the result as a JSON path. We got 2 addresses, one for the external and the other for the internal access. Let's start with the latter by spinning a pod with CURL. Imagine that this is a real application that communicates with that function directly. Now, direct communication is often not a good idea, but I will ignore that for now with the excuse that I want to keep it simple for now. So can we send a request from here to the function? Let's see that by executing curl followed with the internal address of the function itself. And as expected, that worked. And now you might be saying, okay, Victor, stop showing me what works. But bear with me. My crystal ball tells me that the next test will fail if I try to access the function through the external address. So let me exit the curl pod and execute curl with the external address from my laptop. Now, that is a message that is just as useful as my daughter's answer whether we should go biking together. 2 letters. N-O. No. No explanation, no reasoning, no nothing. Just a big fat no. If I make a parallel with my daughter, the only conclusion I can make is that OpenFunction behaves like a teenager. Now, you might be experienced and say that I did not configure ingress or gateway or whatever else OpenFunction might be using, and you would be right. 100% right. I did not configure the gateway API, which, by the way, is what OpenFunction chose to use instead of ingress. That's a great choice, since Gateway API is going to replace ingress, and a fresh new project like OpenFunction should embrace the future instead of the past. Still, going back to you telling me that I failed to configure the gateway, well, the reason why I did not configure it is because I'm sadist. I wanted to share the pain of configuring OpenFunction with you. I want to inflict part of the pain I had when I started using OpenFunction for the first time. That pain, and it's really pain, in part is caused by horrible, did I say horrible? Horrible documentation, and in part by the fact that OpenFunction requires knowledge beyond OpenFunction itself. I dare you to find in their documentation how to configure the gateway. Yep, do it. Do it right now. Pause this video and spend some time trying to find that information. I said that I'm a sadist. I want you to suffer. So go do it. Suffer a bit. Now, so it happens that the external address available in the function CR is not the same as the address generated. Oh my God, generated as routes of the gateway. And that's silly or funny depending on how you look at it. Anyways, let's take a look at those. Let's take a look at routes. Now, that does look like an auto-generated address that should work. So let me store it as an environment variable and send the request to it. And that worked. Praise the Lord. I got my output. Hooray. Hey. Don't ask why those 2 addresses are different, nor how to set them to whichever domain you might want to use. It's not documented or not easy to find. Now, let me see whether I can send a request to the function to store some kind of data in the database. That worked well. Now I can send another request that will retrieve the data from the database, and that also works, right? So that part is working fine. Now let's see which pods are running. Okay, the one with the function is called serving something. That's another silly thing about OpenFunction. I would expect names to have a meaningful prefix like the name of the function. Otherwise, when I start running more functions, I will have no idea which pods belong to which functions. I would need to go through labels and follow the breadcrumbs as if I'm Hansel and Gretel. Okay, that was depressing. It seems that we are going back and forth between the good and the bad, so I guess that the next one should be good one, right? So let me retrieve pods one more time. The serving is still running, right? It's been over 2 minutes since it was created and I want it gone. I don't want to see it anymore. One more kubectl-get pods and there we go. It's dying. It's disappearing into oblivion. Now it's there and the next moment it's gone. Poof. And that's good news. That means that it detected that no one is using it and that there is no need for it to waste resources. It's scaling down to 0, to nothingness. Now, it is not gone forever, right? It will come back if we call it again. Oh, function, where are you? There it is. The moment I sent a request to it, it came back. If I would send many more requests, it would scale to 2 or more replicas. And if I stop sending it requests, it would scale down and eventually disappear. Now, you might say that's all great, but do not want to use functions, or I do not want to rewrite my apps to be functions. If that's what you're saying, I have good news for you. Let's face it, functions might be good for some use cases, but certainly not good for all. Even if a function would fit your needs, you might not want to rewrite your application to be a function. What I'm really trying to ask is, can this thing run my applications as they are? No changes. And the answer is yes. It's a huge yes. It can. You can benefit from OpenFunction even for your existing code bases. Here's an example with a silly demo application I tend to use in my videos. This is a function definition named silly demo that uses an existing image. It has the serving template section that does not contain anything special, and the serving triggers section that defines the HTTP port through which I would like to access my application, that application. It might be misleading to call that definition function, but that's what OpenFunction chose to do. Now, the interesting part is that I did not specify the build, meaning that I do not expect OpenFunction to build my image, but only to run it as a serverless application. That over there might be useful if you already have a process that builds container images and you want to reap benefits of OpenFunction to run it. Alternatively, you can say, hey, my building process is not that good anyways. I will let OpenFunction build it for me, but I do not want to use build packs. I want to use, let's say, Kaneko that will not guess what it should build, but use my Docker file. In that scenario, a modified version of the manifest you just saw could look like this. Over here, I did add the build section, but this time the builder is different. I chose it to be Kaneko and to use Docker file. Further on, I specified that shipwrite, the OpenFunction build orchestrator, should use the cluster-wide build strategy based on Kaneko. Finally, just as before, I defined the repository from which it should get the source code and Docker file. The important thing to note is that I did not change the source code of the silly demo repo in any shape or form. It is the repository of an application that I used long before I discovered OpenFunction. That is one of its superpowers. We can adapt our applications to OpenFunction, or we can leave them as they are and still benefit from many of the concepts it introduces. Now, I can just apply that manifest, and if I list all the functions, we can see that silly demo is there and that it is currently building the image. That will take a while, so let me fast forward a bit, just a little bit, and voila, it's running. There is only one more thing I want to show by outputting all the resources running in the A-team namespace. This is the list of resources that are currently running, and there were quite a few others that are ephemeral and are not even listed here. There are, as you might expect, the pods of the applications, but there are also services, deployments, Knative servings, revisions, routes, and so on and so forth. I'm showing you all those to discourage you, and I repeat, discourage you from trying to build something similar yourself. There's a lot going on here while still managing to keep it very simple and intuitive to end users, to people who just want to run their functions, their applications, or any other type of workloads as serverless computing. On the other hand, in the spirit of finding a bad thing for every good one, there is yet another problem. Naming is... oh my god. Naming is horrible. Honestly, it's horrible. Most of the names are kind of random, at least from the perspective of someone who is not familiar with all the components related to OpenFunction. That's not a problem when everything works as expected. But when the time comes to debug an issue, and that is bound to happen sooner or later, believe me, you will need to spend considerable amount of time figuring out what is what. Again, and I'm not even going to dive into observability and other things that you should be doing, which are also going to be horribly complicated because of the mess that OpenFunction creates with low-level resources. Now, if you think that what you saw so far is good, wait until you hear what else OpenFunction can do. The demo only scratched the surface of what OpenFunction can do. Honestly, there is much more. Besides being able to build images in a variety of ways and running applications in a synchronous, serverless way, we can also run them asynchronously through event-driven models. Those events can be hosted in Kafka or other places. We can run apps as containers in Docker and Kubernetes, but also as WASM binaries. We can define scaling through Knative or KEDA. We can connect to backends like databases, queues, and other services through Dapper. We can trigger scaling not only through HTTP requests, but also through events. We can expose our applications through any gateway API service. We can even instruct OpenFunction to watch for source code or image changes and rebuild or redeploy images. I probably missed quite a few features, but in the interest of time, I'll skip through those and we can move towards my favorite part of the video. And you know what that is, right? At the very beginning, I quoted the official description by saying that OpenFunction is a cloud-native open source PaaS or functions as a service platform aiming to let you focus on your business logic without having to maintain the underlying runtime environment and the infrastructure. I got tired just by quoting the whole sentence. I also said that that sentence is bollocks. It is not FaaS only, and the claim that there is no need to maintain the underlying runtime environment and infrastructure is completely false. First of all, as you already saw, OpenFunction is not only about functions. You can indeed run functions, but as you saw, you can run any other type of applications as well. It uses Knative just as Google Cloud Run uses it, and that means that almost anything packaged as a container image can be run through OpenFunction. That does not mean that anything is a good fit for it, but there are certainly non-functions that you could, and you should run through OpenFunction. It is not containers as a service either, since it can run WASM as well. The simplest way to describe it would be to say that it is open source containers as a service platform, but that would not be true either, because of the second reason why I said that the quote is untrue. OpenFunction cannot claim that it aims to let you focus on your business logic without having to maintain the underlying runtime environment and infrastructure. You certainly need to set it up yourself. You need to maintain the cluster where it's running. You need to maintain all the components that OpenFunction combines, and you need to maintain OpenFunction itself. So I would describe it as following. OpenFunction enables SREs to set up a serverless platform that will let developers focus on their business logic without having to maintain the underlying runtime environment and infrastructure. It is a tool for SREs or DevOps or sysadmins or whatever those roles are called today to provide a part of the solution that will enable them to enable developers to focus on their business logic. It is one of the pieces of the puzzle towards shifting left and towards having an IDP. It is a big piece of the puzzle, but it's still only a piece. Now, let's jump into pros and cons, and let's start with bad things. To begin with, OpenFunction builders are not maintained frequently. The one I used in the demo was last built a year ago. That's one of the reasons why the image showed 5 vulnerabilities in my container image registry. Next, it is not a platform for developers who should focus on the business logic. Now, under different circumstances, I would not count that as a negative thing, but the official description of the project claims that it is. So let me explain it differently. OpenFunction is not built for developers only. It requires a strong ops team. It requires people who know in depth not only Kubernetes, but also Knative and KEDA and Dapper and other components. You will need those for 2 reasons. First, someone needs to set up everything. That task is complicated, not only because it requires deep understanding of Kubernetes and the components OpenFunction uses, but also because the documentation is horrible. And that leads me to the third con. Documentation is horrible. It is very superficial, and you will have a hard time finding information, and even harder time finding workable examples on how to do something beyond the quick start, which, by the way, does not show even a fraction of the features. For example, I dare you to find a way to specify the host of a service. Now, you might say that we should go not only through the OpenFunction, but also through the documentation of all the projects it uses, but I think that would be silly. OpenFunction is trying to be a project on its own, and that means that it should provide all the information needed to use it. You cannot expect me to go through documentation of all the other random projects it uses. It should give it to me in one place, right? Because it's a project that tries to put all that in one place. Next, it currently supports only Go, Node.js, Python, and .NET. That might happen to be what you're using, and if that's the case, great, but it might easily not be. You might be a Java or a Rust developer. Now, to be clear, that limitation applies only to using OpenFunction to run functions created using its own libraries. And you can still run it as a normal application written in anything you want, with only a few limitations. Moving on, resource names could contain function prefix to distinguish them. Otherwise, it's a nightmare trying to figure out which are all the resources created as part of a specific function or application. What else? Yeah, some things are half-baked and not really thought through. CI/CD, for example, is very, very green, and most of the time it does not even work. Next, images are built every time we deploy the function to a different namespace or a different cluster. That's a terrible waste of time and resources and can result in discrepancies between environments. It would be much, much better if it would build images only if they do not already exist in a registry or if we explicitly tell it to do so. Now, I might be wrong about this and other negative things, about other cons, but as I already mentioned, documentation is horrible. And I believe that something not documented or hard to find in a docs is as good as not existing. What else? What else? Oh yeah, there is no option to plug other SDLC steps like testing, for example. If I should use OpenFunction to build and run my apps, it would be reasonable to expect that testing is there as well. There are other steps in the SDLC that would be a great addition, but testing, come on, it's a bare minimum, right? You cannot expect me to use a tool to build and deploy an image without testing before, during, after, what's not, right? So it's definitely not a CI/CD solution as the doc says. Now, I would understand that the project does not want to expand too much. However, Tecton pipelines are already part of the setup, and it would make sense if testing is included in the OpenFunction flow. Finally, I do not think that the support for Docker brings any tangible benefits. Now, this is not me trashing Docker, even though I did that in the past. As a matter of fact, I'm moving back to Docker slowly for reasons I will not explain here. The reason I do not see the benefits of supporting Docker lies in the complexities of having functions in the first place. Functions almost always have dependencies. They might need to talk to other functions, to databases, to queues, and so on and so forth. If OpenFunction aims at being run in Docker, it should solve those problems. Dapper is already there, it's included in OpenFunction, and it does solve some, if not all of those problems, but OpenFunction itself fails short to show how to use it effectively in that context. As a matter of fact, it fails to show how to use Dapper well in almost all other contexts, but I already mentioned that when I complained about the documentation, so I will not repeat myself. Now, that was a long list of cons, right? I could easily make it double the size, but I'm getting tired of listing all the bad parts. So let's switch to pros instead. OpenFunction is easy for the end users, the developers. Now, that part is true only and exclusively after it is set up well and combined with a few other tools and processes. Nevertheless, if we do things right, developers will be able to focus on their business logic and not worry about anything else, at least in theory, right? What I'm trying to say is that an experienced SRE or DevOps or whatever you're calling yourself can set up OpenFunction in a way that will make it easy for developers to use it. Among self-hosted, and I'm talking exclusively about self-hosted solutions, OpenFunction might be the project that is closest to the shift left goal, and at least when applications are concerned. And that leads me to the next pro. OpenFunction is probably the best choice for ops who want to enable devs to focus on their business logic. It combines all the right tools and glues them all together. If I would build a solution like that myself, I would probably end up with something very similar to OpenFunction. I would choose Kanico or BuildPacks to build images. I would use Shipwright to orchestrate builds, Knative to run applications, Dapper to connect to backends, and so on and so forth. Next, Yes, it is not very opinionated. Or to be more precise, it has just enough opinions to be helpful and save us time from building something similar, yet it is flexible enough to allow us to shape it to our special needs, whatever the needs are. The flow itself is certainly opinionated, but the tools are not. If you don't like build packs, you can use Kaneko. If you don't like Knative's ability to scale, you can use Keda. Let's see what else. Yes, it is serverless from the end user perspective. There are certainly servers involved in every serverless solution, and since this is a self-managed solution, someone, that could be you, must manage those servers and everything else. However, it does solve some of the problems that are typically solved by serverless workloads, like, for example, scaling. If not used, your application will scale to 0 replicas and stop wasting resources. When it's used, it will scale to 1 replica. When there is increase in traffic, it will scale to more replicas, and when that traffic decreases, it will scale down. That makes it perfect, not only for production, but also for other environments, especially ephemeral ones like those used for previews and testing. Finally, it can run as Docker containers in Kubernetes or as Wasm. It's up to you to decide how useful that is or isn't. All in all, there are many good things, but also many bad ones. Now, you might say that the bad parts are scary and might make you choose to wait until the project matures. That's certainly an option. However, if you do need something like that, I can argue that stitching it all together yourself might take a lot of time, and it will likely result in even more problems. In other words, OpenFunction is not perfect, but it's probably the best option we have today for such solution, right? Integrated solution. The alternative is to combine many of the same tools yourself. If you do consider using it, I would say go for it, try it out, but only and exclusively if you or someone in your organization is very experienced with Kubernetes and the tools OpenFunction uses. Otherwise, you will run into problems and you will not know even where to look. Thank you for watching. See you in the next one. Cheers.